Okay. So let us start the addressing modes in 8051. So what is mean by addressing modes? Addressing modes basically refer to the way in which CPU access data. Okay. Now the data, there are two things. There are data and there is program in 8051. So the data could be stored in either register, okay, in RAM area, or it could be in uh, memory, either internal memory or external memory, internal RAM or external RAM. Okay. Uh, you must be wondering why I am telling that data could be in uh, ROM. We do store some of the data in ROM also, such data which are required by the program every time it is running. So such data needs to be stored somewhere in the ROM location, and we do not want it to be we do not want it to vanish when the program 8051 is reset. Okay. So it is basically stored in lookup table. Anyway, so the RAM and ROM locations in which data is stored. Then uh, so how the CPU access these datas? So the way CPU access these data is referred to the addressing mode. Okay. So there are various addressing modes in 8051. So what are they? I'm just listing them down, and then we would be taking one by one. So the first one is called the immediate addressing mode. The second one is the register addressing mode. The third one is the direct addressing mode. Then the fourth one is indirect addressing mode, and the fifth and the last one is the indexed addressing mode. Okay. So these are the five addressing modes that are available in 8051. Now we will look into each one of them in detail. Okay, so let's start with the first one, which is the immediate addressing mode. Immediate addressing mode. So in the immediate addressing mode, the source operand is constant. Okay, operand is the data on which some instruction carries out some operation. Okay, so in immediate addressing mode, the source operand is constant. So I am writing down one instruction, and you will understand what it means. I am writing down one instruction: move a comma hash 25h. So what it means, this instruction, what it means? It means, so let me tell you about move instruction. Move instruction is basically moving some data or content of some memory location from one place to another. And that is basically a copy paste feature of 8051. It is not cut paste, it is copy paste. That means whenever you are taking data from some other place and you are moving it to or copying it to the accumulator or any other register, then you are basically copying it, and the original data remains from where it was taken. Okay, so what this means? This means that uh, a the number 25 is a data, and it is being copied to A. This is what it instruction means, and this hash is preceding this number 25, and this basically refers, this implies that this number 25 is a data. This is a data and not an address. Okay, because 25H could be an address. If you see the memory map, the RAM map, you will see that 25 is a address. Okay, so hash proceeds or precedes this numbers to show or to make the 8051 understand that this 25 is actually a data and not address. So that data is directly being transferred or copied into register A. Okay. So that is why it is called immediate addressing mode. So direct transfer of or copying of data into the register. Okay. It is not the 8051 is not looking into some memory location and fetching out data from there and copying it to it. Rather, it is directly copying this data into register A. Okay, or it could be move, say I'm writing one more instruction, R4 hash, say 62H. So what it means, that the number 62, because it is preceded by this hash sign, so this 62 is a data, and that would be copied to the register 60 R4. Okay, now whether R4 is in bank 0, 1, 2, 3 is it will be known if you have done some coding before writing this instruction R4. If there is no instruction before this move R4 comma hash 62, by default I told you that bank 0 is selected. That means all registers of bank 0 are worked upon. Okay, or we could have instruction like move B comma hash 40H. Okay, or we could have move dptr comma hash 4251x. Now dptr, as you know, is a 16-bit register because it consists of two 8-bit registers, dpl and dph, isn't it? So writing this instruction basically means transferring the 16-bit data into dptr. So definitely it is going to take a longer time compared to these instructions in which 8-bit copy pasting of data is there, isn't it? Now the same instruction can also be written in this way, like move dpl comma hash 51h and move dph comma hash 42h. So result of this instruction and this single instruction is same. dptr will have a value of 4251. Okay, so I hope you have understood what is meant by immediate addressing mode. Please remember that whenever you are writing a number, that has to be preceded by a hash sign for the microcontroller to understand that the number which it is dealing with is a data and not a memory address. So this is immediate addressing mode. Fine, any doubt here? And definitely the data that you are transferring should be an 8-bit data. Other than this, all of them have to be 8-bit data, otherwise the microcontroller will generate an error. Any doubt? Okay, let's move to the second type of addressing mode, which is called the register addressing mode. the register addressing mode. So register addressing mode basically involves the use of registers to hold the data that we are working on. Okay, so let me write down some of the instruction and then it would be more clear. So move a comma r naught, or say move r naught comma a. Okay, so these are some of the examples of register addressing mode. So what it means now? So basically it means that the content of R naught is being copied to A. Okay. So if R naught was having a value of say 25H initially before writing this instruction, then after this instruction A will now have value 25H and R naught will have a value equal to, yes, how much?
25H.
So we,
25H.
okay, why? Because copy pasting operation is being done. It is not cut paste, it is copy paste. Fine. Similarly, if I write down this instruction, uh, what will happen? So now whatever is there in A will go back to R naught. So since it was 25, again R naught will already was having R naught 25. So if I write here say R2 here, so then after this instruction R2 will have value 25H. And what would be the value of A? It will again be 25H. Fine. Is it fine?
Yes, sir.
Okay, so one more important thing, move R0 comma R1. This instruction is not a valid instruction in 8051. That means moving data from one register, one general purpose register to another general purpose register is not allowed. It is not allowed. So we can carry out this same operation. What this operation intend to do? Copy the content of R1 to R0, but it is not allowed in R8051. So we can first copy the content of R0 in A and then copy the content of A in R1. R1 to R0, sorry. So here it will be R1 and then R0 to A. So first it will copy R1 to A and then the content of A will be copied to R0. Okay. So this is not a valid instruction in 8051. Why is it so? Why is it not a valid instruction? Because if that be the case, you see then how many move instructions would be required. So actually each of these move instructions has an opcode. Okay. I don't think I have talked about this opcode. Actually, each of the instruction is associated with an opcode because microcontroller is not going to understand this. This is assembly language. Assembly language. Okay, so microcontroller do not understand assembly language. It basically understand things in 0, 1. Okay, or machine level language. So higher than machine language is your hex code. Hex code, which in which these instructions and the numbers, they are actually written in hex. Okay, so opcode is basically something in hex, written in hex. So this instruction is also has some reserved uh, hex code or opcode. We call it opcode. Okay, which is generated in the 8051. So we write the program in assembly or maybe in some higher level language, say C. Then it is converted into by some assembler. It converts this higher level language or assembly language into machine level language. Okay. Then only 8051 is able to understand what it has to do. Is it fine? So I was talking about why this instruction was not incorporated in 8051. It was done by the design engineers who had actually designed this 8051 microcontroller, and the reason was that if they would have allowed this instruction, then a massive amount of opcode would have been required to carry out the various operations associated with each of these general purpose registers, because there are 7 registers, okay, in each of the bank, because each bank will have a different R0 and R1 address would be different. So this opcode, move opcode would be different, isn't it? Then the problem is the other instructions, like apart from move, we have other instruction also, like add and all those instructions. Then each of them would be requiring a massive number of opcodes to carry out these operations. So they have just dropped this idea of using this instruction, and instead the same operation can be carried out in these two simple steps. Is it fine? Okay. So we were talking about register addressing mode, and these are the valid ways of uh, using or programming in register addressing mode in 8051. Okay, let's come to the third one, which is direct addressing mode. The direct addressing mode. Okay. So in direct addressing mode, what is done? Uh, the operation is on the memory address directly. Okay. So I'm writing down one instruction: move a comma say 25h. Okay. So just see, I haven't used this hash sign here. I'm writing move a comma 25h. So this implies that the content of 25 is a address, okay, in RAM location, okay, not ROM location. Why RAM location? Because data is in almost all the data are in RAM, not in ROM. So always the address would be referring to RAM, unless otherwise we are using some other instruction which I will come, which is called move C instruction, in which ROM is involved. Otherwise move instruction is for RAM. Okay. A comma 25h. So 25h is an address. It is a RAM address, and the content of 25h. Now 25 is not moving but content. So symbolically we write the content in this bracket. Okay, so that this means content of 25 is moved to A. This is what is mean when we write move A comma 25h. The content of 25 is copied to A. So if the memory location 25h, it was containing say 52h data, then after this instruction A will be equal to 52h. And similarly we could have the other way out also, 25h comma A. So that means now the content of A would be copied to the memory location pointed by 25h. Okay. Sorry, not the memory location pointed. Sorry, the content of A would be copied to the memory location 25. Okay. And similarly, we could work with the registers also. the general purpose registers here. Move R4 comma 7FH. So what it means, moving the content of 7F, whatever is there in 7F is moved to R4, copied to R4 register. Okay. So any doubt with direct addressing mode? So I hope you do understand the difference between this instruction move a comma hash 25h and move a comma 25h. Okay. So let me quickly ask one question. So say for example I have got a memory location 25 and there is a number say 52h located here. Okay, and A has got say 20h. Okay, now I'm writing down one instruction, move a comma hash 25h. Okay, now tell me what would be the result of this operation? What would be there in A?
25H.
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 What would be there in 25h memory location?
52H.
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 52h. Why? Because we are not doing nothing with the memory location 25. So 52 was there, it will remain there. Okay. Now let me write one more instruction. Move a comma 25h. 25h. Okay. Now tell me what is a?
52H.
52H.
It is 52h. And what about 25h?
52H.
It is
52.
52h. Okay. Let me write one more instruction. Move 25h comma a. Okay, let me write first one more instruction, a comma say 32h. Okay, then I write move 25h comma a. Okay, so tell me after this instruction, after these two instruction, what is a and what is 25h? What is there in 25h?
तो
In a
32H का डैश आएगा.
it is 32h, and what about in 25h?
सर हैश नहीं आएगा तो 32H के आगे एक मूव फंक्शन में.
Okay, sorry. Yes, so A will be have 32h, and what about 25h? What will be there in this memory location?
32H.
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 It's simple. Okay, is it simple? Fine. Now let us move to the another mode of addressing, which is the indirect. It is, I think, fourth one. Indirect addressing mode. Okay. Okay. So in the indirect addressing mode, basically a register is used as a pointer to the data. Okay, a register is used as a pointer to the data. And if the data is inside the CPU, only register R0 and R1 are used for this purpose. Okay. So let me take an example and it would be more clear. So I'm writing down one instruction, move a comma at the rate R0. Okay. So what it means now? So it means whatever is there in R0, say R0 was containing say 25H. Okay. So if R0 was containing 25H, so this instruction means that the address pointed by R0, so which is 25H, the content of that would be copied to A. So if 25 was, this is the memory address, it was carrying say 52H, then after this instruction, A would be having the value, 52H. 52H. Okay. Is it fine?
So 25H is the address of R0.
R0 is containing 25, and this instruction, I'm using this at the rate, that means the content of the address pointed by R0. Okay, listen to this one again, once again. The content of the address pointed by R0 will be copied to A. So R0, if it was containing 25 and the content of 25 is say 52H, then this 52 will be copied to A. And after this instruction, A will be having the value 52H. Similarly, if I write move A comma at the rate R1, okay, and say R1 is having a value of 35H, say, and 35H is a memory location, and it is having say a value of say 10H. So after this instruction, A will have a value of 10H. Okay. Tell me, is it clear?
Yes, sir.
And the other way around is also possible. That means move at the rate R0, at the rate R0, comma A. So that means the content of A would be copied to the memory address pointed by R0. So if I take this same example here, so R0 was carrying 25H. Okay. And 25H was having a value of 52. So after this instruction, 52H, which is the memory location, 52H, will have a value of A, and say A is 10H. Okay, say A is 10H, then 52H will have a value of 10H. Is it fine?
So,
And
but here,
yes.
so but here the address pointed by R0 is 25H, na?
R0
Yes, sir.
is 25H. Okay. Address pointed by R0 is 25H. Okay. And 25H will have some content. Just understand it once more. Okay, let me take a fresh page and let me write down this instruction again. So move at the rate R1 comma A, and let us refresh everything, and let us take say A is having say 32H, and say R1 is having say 55H. Okay. And say 55H is the memory location, and it is having in some value only 35H, say. Okay. So what will happen here? So content of A is 32. Where it will go? It will go to the address pointed by R1. Okay, R1 is pointing towards 55H. So now earlier it was 35. 55 was having 35, but after this instruction, now 55H will have a value of 32H. Is it clear?
Yes, sir.
So did I mistake in the last example?
Yes, sir.
Yes, sir.
Okay, okay. Sorry for that. Okay, okay. So I think it is now clear. So this is one of the most powerful way of addressing in 8051 in any other programming language, the indirect mode of addressing. And I think more than 90% of the programming use this indirect addressing mode. Okay. Is it fine?
Yes, sir.
Okay. So let us move and let us take up the last one, which is the indexed addressing mode. Indexed addressing mode. So index addressing mode is actually, it is widely used in accessing data elements of lookup table entries located in program ROM. So most of the time when you will see that program using indexed addressing mode, it would be involving ROM. So data that are stored in ROM, I had told you that some of the data might be located in ROM because they need to be accessed multiple times, and every time when the microcontroller is reset or restarted. So we do not want those data to be stored in RAM. We store them in ROM. I will take one example and it will be more clear. So this indirect addressing mode basically pertains to such type of data. Okay. So let me take one example. So move C. Now see what I'm using. This is a different instruction. Move C is used for ROM. Okay. To access the data or to copy the data to ROM of 8051. So move C instruction is there. So move C A comma @ A plus DPTR. So this is a general instruction of how the index addressing mode looks like. So what it means? So normally data are stored and the memory location are in DPTR. Okay, data pointer. So data are normally stored in sequential form in the memory. Say for example, it starts from 4000H, the next data is 4001H, 4002H, and so on. Okay, and you need to write data here or you need to fetch data from here. Okay, so what is done? You don't have to change the content of DPTR. You cannot change it. You can change this A. Okay, so as in the previous case, @ basically implies the content of the memory location pointed by this sum. Okay, so if A is equal to 5, so that means DPTR plus A, DPTR, say it was containing 4000, so it is 4005H. So if I increase just A, I will be, say, increase it by 1, then I move to 4006H, the content of 4006H. If I increase A by 1 more, then I will have the access to memory location 4007H, and so on. Okay. So the data that are stored in ROM in sequential way can easily be fetched, or we can write data here in these memory location very easily with the help of the indexed addressing mode. Okay, is it fine? Yes, please. Anybody having any query, they can ask me. Any question?
सर इंडेक्स एड्रेसिंग मोड एक बार और बता दीजिए.
अच्छा, एक मिनट. तो एक एग्जांपल मैं आपको ले रहा हूँ. ओके, सो 7 सेगमेंट डिस्प्ले आपने देखा होगा, कुछ इस तरह का होता है. ठीक है, देर आर 7 लाइन्स एंड दे आर LEDs होती हैं normally. So if you want to display one in this 7 segment display, what you have to do? You have to light this B and C. Okay, similarly 0, that means A, B, C, D, E, F, and you can just generate any number from 0 to 9 using this LED display. Okay, now what happens? Say for example, take the case of traffic light or any place where you use these 7 segment display. You want these numbers, okay, you want to store the code of these numbers to be displayed on the 7 segment display. ठीक है, तो for example, so A, B, C, D, write means like this: A, B, C, D, E, F, G, and this last one. So last 4 bits and these 4 bits, these all are 0. Say I want to display 1. So what I have to do? I have to make B and C 1. So this is 0, B and C are 1, and this is 0. So this comes out to be 0, and this is how much? This is 5, I think. 5H. So this 05H is basically a code for generating the number 1 in LED display, 7 segment display. Okay. Similarly, if I want to display 0, then all these values will be 111 except this 0. So 0, 1, 1, 1 and 1, 1, 1, 1. So this is F and this is how much? ये कितना होगा? I think 7. 7F H. Okay, so these numbers are basically stored in ROM. Say I am storing these numbers are basically referred to codes in LED 7 segment display. So I am storing these numbers, say starting from 4000H, 4001 1H, 4002H, and so on. So at 4000H, 0, 0H, whatever is there corresponding to 0, I think. Oh yes, 7H. It is 7H, 7FH, and then so on till so 4005 में हमारा say 5H, 5H. Okay, 05H and so on. 4007 में शायद 07H होगा. Anyway, so these numbers are the codes which need to be stored permanently in ROM in 8051, because these need to be accessed by the program time and again. Say for example, in case of traffic light, you need to blink some numbers. Okay, for that these codes needs to be accessed. So how these codes are accessed? Accessing them individually makes the program lengthy. So what we do indexed mode of programming, in which move a comma at the rate a plus dptr. So I store 4000 in dptr and I increase the value of a according to the situation, whatever number I am interested in displaying. Okay, so the number that are stored in the memory location ROM, this is move C a comma this one, will be copied to A, and then you can display it. Okay, are you getting my point?
Yes, sir.
So this is how it works. So basically it pertains to accessing memory location of ROM, the data that are stored in ROM. Either we can fetch from there, or we have to write it at that memory location in ROM. We can use this index addressing mode to copy a set of large data, okay, from ROM to a different location, say at the port where we intend to display, use it for 7-segment display or some other function. Okay. So this was all about various addressing modes in 8051. Okay, and so I think time is also over. So if